Hey everyone, welcome back to Swift Fundamentals. Today we're tackling two crucial topics, error handling and initialization in Swift. By the end of this lesson, you'll know how to handle potential errors safely using try, catch, and do blocks, as well as initialize objects with different initializer types, including failable ones. Let's go ahead and dive on in. All right, so Swift uses a robust error handling model. Errors are represented by types conforming to the error protocol and managed using try, throw, and catch. So let's go ahead and we'll make an error type conforming to the error protocol, and we're actually going to do that using an enum. So I'm going to create a enum up here, and I'm going to call it validation error. And then I'm going to say that conforms to the error protocol. I'm going to add my brace here. Let's add a case for empty field, and we'll add another case for invalid email. Cool. Let's now create a function that's going to throw an error if an input is invalid. So I'm going to create a function here, and we'll call it validate email. I'm going to add my parameters, and I'm going to say underscore space email, which is going to be a string. And then outside the bracket, I'm going to say throws. I'm going to add a brace, and we can add some code in here. So let's go ahead and create a guard statement. So I'm going to say guard. I'm going to use my exclamation point for opposite. Email dot is empty. Else. I'm going to add a brace here. Throw. And then we're going to reference our validation error dot empty field. So this is going to throw the error for the empty field. Let's go to the end of our else statement here. We'll hit return for a new line. Say guard email dot contains. And then within here, we're going to put the @ symbol as a string else. And then down here, we'll say throw validation error. And let's reference that invalid email. So this is going to throw the error for the invalid email. All the emails need to have that @ sign within them. So the validation error represents possible error cases, and the validation email checks for valid input and throws appropriate errors. So now let's explore handling errors with do and catch. So down here, I'm going to create a do statement, and I'll say do. I'll add my brace. I'll say try, validate, and if you've watched any of my SwiftUI tutorials, I do these a lot. Email, and then we'll put invalid email.com. So we're missing that @ symbol, but we're going to attempt to validate, and we're going to print email is valid. Now down here on our kind of closing brace, I'm going to add a catch, validation error dot empty field. Use my autofill feature here. I'm going to add our brace, print error, the email field is empty. This is going to handle specific error. Then at the end of this brace, we're going to add another catch. And we're going to say validation error dot invalid email. Add a brace again, and we'll say print. Again, when you're actually creating the code, instead of print statements, unless you're debugging, you'd actually want to have different code snippets handle the actual logic here. So I'm going to go ahead and print that the email is invalid. Just for consistency, I'm just going to put error at the start of this one as well. Great. And you can also interpolate errors within these print statements as well. Great for debugging. And let's do one more catch statement here. I'm going to add my brace, and we'll print error. Right, and I'm just going to go ahead and toss that error statement in here. So we're using try to call a function that may throw an error, and by using the do catch, we can handle errors, including specific and general cases. And you can see when we run our program, the email is invalid. All right, let's go ahead and change it. So invalid email, let's just add the @google.com. Let's go ahead and run our program one more time. And because our email has gone through, it will say email is valid. And if we have an empty string, let's go ahead and see what happens in the console. Error, the email field is empty. So we can see based on the conditions that we've set up with these tries and catches, we're able to handle any error that might be coming our way. Again, instead of the print statements, you might want to create actual code in a running program to handle those different catches and scenarios. All right, let's talk about initialization in Swift. So these are what's going to be able to have us set up new instances of a type. Swift provides default, custom, and failable initializers for flexibility. So I'm going to create a new struct up at the top here, and we'll call it user. We'll add our brace here. We'll create a variable for name, which would be a string. Sorry if Xcode's a little bit laggy here. And we'll create another variable age, which will be an integer. Great. Let's now create a custom initializer. So we're going to say initialize by using init. And you can even see with the autofill feature, it'll create that name, string, age, and it'll reference the lowercase self for both of those variables. So init uses the properties with required parameters. The user instance is created with a name and age. So let's go ahead and go down here. Let user equals user. Go ahead and fill in those name and age. Alice, age 29. Oh, but 39 apparently. That's going to create a user instance. Let's go ahead and print it so we can see it. User. Go ahead and then interpolate the user.name, the age, all right, let's go ahead and run our program. Oh, I'm sorry, it should be user.age. Let's go ahead and run our program. We have user Alice, age 39, and let's create another one. Let user 2 equals user. I'll do myself for this one. We'll do Noah, age, I'll never tell. And then we'll print out the exact same thing. See how this looks. Great, so we have user and user 2, both with those different instances created with a different name and age. All right, let's talk about the failable initializers now. So I'm going to create a new class here, and I'm going to call it person. And let's add our variable of name and age again. So the name would be a string, and the age again is an integer. And we can create a initializer here, but what we're going to do is where it says init, we're actually going to add our question mark operator. So this is going to add the failable initiator in order to validate age. So what we're going to now say in our code brace, so above the self name and age, I'm going to create a guard. And I'm going to say age greater than 0, else return nil. So this is going to essentially return nil if the age is invalid, right? We can't really have someone who's less than a year old or less than 0 years old, right? You would cease to exist at that point. So let's go ahead and create an if let down here. Let's say person equals person. Let's go ahead and plug in that age down here. So I'm going to create someone named Bobby. And let's have the age be, I don't know, -10. Bobby is a time traveler, apparently. Add a brace, and we'll print person created. Let's interpolate that person.name, comma, and then we'll interpolate the person dot age. Okay, we'll go down here and we'll include an else statement. And we'll say print invalid age could not create person. All right, let's go ahead and run our program and see what happens. It's going to say invalid age could not create persons. If we were to change this to be an actual age, let's say Bobby is 15, person created Bobby 15. So essentially what's happening is the initializer with the failable allows initialization to fail by returning nil. We use this if letdown here to handle optional instances created by a failable initializer. So let's go ahead and combine everything we've learned here to create a robust class that validates input during setup. So I'm just going to go ahead and delete everything here. So Command A delete. We'll create a new class. I'm going to call it account. And within this, we're going to have a variable for username, which will be a string. Then we're going to initialize the username string here. We're actually going to change this up a little bit from our template though. We're going to say throws, and then we're going to have our guard. We're going to use our opposites, our exclamation point operator here. Username dot is empty. Then going to create an else statement. And from here, we're going to throw a validation error, which we have yet to create, dot empty field. So this is going to throw error empty usernames. Again, if you're creating a sign up form, this is really perfect for you. Then we're going to have our self.username equals username. Perfect. Let's go ahead and create a do statement down here. So do, and we'll have let account equals try account. Let's go ahead and plug in that username. And for the string, let's actually just make it blank. So I'm just going to add the quotations, not even a space in it. So we're going to attempt to create an account. We'll then print account created. And let's go ahead and interpolate that account dot username. Cool. After the do, let's put our catch statement here. We don't catch any of those errors. Print error creating account, and then we'll interpolate that error here. Let's then create our enums from above. So enum validation error. And let's put it under the protocol of error. And in here we'll create the cases, and we'll have empty field and another case of invalid name. Alrighty, well, let's go ahead and run our program and see what happens. Error creating account, empty field. Okay, and let's go ahead and now put something within the username. I don't know, Ricky, Bobby. Let's run the program. Account created, Ricky, Bobby. Amazing. I did create two cases in my enum, so if you wanted to have something where if you're preventing certain names or certain characters, right, maybe you want something that, doesn't have a swear word in it, right? It's up to you how you want to kind of handle those different things, but essentially the errors are being thrown in the initializer for the invalid input, and we're using the try and do catch to handle errors when creating an instance. So that's it. Today we learned how to use try, catch, and do blocks to handle errors and explore initializers, including custom and failable ones. These techniques are essential for writing safe, reliable Swift code. Again, I'm using the print statements. Think about how you can handle logic within all of these. Thank you so much for watching. Don't forget to like, subscribe, and if you want to, you can drop a comment for your favorite error handling tip. But as always, dream big, code bigger, and have an amazing day.